Good morning. My name is Sonic, and the owner of Sonic Motorsports, Savannah, Georgia. And today it is such a great honor to have these two very talented youth from Savannah Technical College and assisting us on the project of restoring vintage Formula Ford that owned by Michael Andretti back in the days. So let me introduce something that we find out and we're having question about. It's very interesting. So the situation is during the restoration project, the chassis originally had a big impact and actually deformed, bent into a degree. So it's pretty straightforward. We were removing the original deformed sections and we replace them with new sections. Now, in order to make it more visualized, here's, say, this is the original section, this is a new section. We're trying to butt join them together to form one piece. However, everybody knows only weld on the surface may not be strong enough. So our plan was to sleeve another tubing inside. That's not the correct tubing we're using, but just for showing. And then we join two pieces of metal together. We have holes created around the new outer material, and we plug weld, fully penetrate into the sleeve tubing to make sure everything is fully attached, as we can see from this layout. And so this represents the outer layer of this metal tubing, and this hatched section is representing the inside tubing. And they were held together by several holes created and the plug welded. So that holds everything in place, strong as well. And what we're having debating is the section that we butt joined. And so are we going to have penetration that going through the top surface to the bottom surface of this outer tubing wall, and only penetrate that much and stop over there? Or we actually have a deep penetration that penetrates through both the outer layer and the inner wall of the inner tubing. My concern was if we only have a sufficient penetration to the outer layer, down the road if fatigue happened and inducing crack, and then the crack will start from the outer surface and stop at the end of the top layer. So it will not keep penetrating down. It will not affecting the inner tube. So which means it still carry sufficient strength to take bending load. However, possibly if we're having a full penetration between the inner and outer tubing, then chances are the crack will start from surface and go all the way inside, or vice versa from inside out, and to affect both layers. So that way we lost the whole strength. By doing that, and these two talented young gentlemen, Parts and Ron, they did some samples and run the testing at a school facility with their, what's the machine called?
Bend test machine.
Bend test machine, and of course with a great effort, help from Professor Marcus Law, who is by chance today is teaching. So hi Marcus. And so here's the video of what we find out.
The piece is clamped in about 1 inch into the vise, so we can get a good bend across. Actually, I'm going to loosen it up, bring the stress point a little bit closer to the actual bender, so about 1.5 inches worth of material in the jaws. Not too tight of a fit, so we don't press the material too much, just enough to hold it. Gonna go for about a 30-degree bend, flip it around, try to bend it back, go back and forth until we see a failure. So as is, the closer plugs are on the inside toward the actual bending wheel, and then the farther plugs are on the outside. So 1, 2, 3, bending in. So luckily, there's enough strength that it does not seem that it damaged the piece more than just some compression. It seemed to have more just bent at the clamp. So a little bit of compression here on the top at the jaws, nothing so far here. I'm going to stick it a bit further in, right at the end of the sleeve, so that we get both sleeve and outer tube in the vise. Give it a bit more clamping force to make sure that it doesn't stretch like it did before. And we're going to go one more time, hopefully see some bending on the weld joint itself. So bending. Alright, got about 15-20 degree bend. It's destroying the tube, but that's kind of the point. Ideally, the weld should fail after the base material. Weld did fail. Okay, so weld split along the weld joint.
So that was not the full pen. I messed that one up. That was not the full pen.
Did not fully penetrate in. There is some full penetration, as you can see right here. However, the plug welds are still holding. There is no compression. It's a lot of compression right here. So you can see about a 15-degree bend. This is far more than any kind of natural stress would occur. We're going to flip it around. I'm going to clamp here. But even then, like this much, you're not going to get that much. Yeah. But the plugs are still holding because the inner sleeve is still there. So what I'm going to do, I'm going to flip it around. I'm going to clamp on this side, right where the tube, the inner and outer sleeve meet, and then we're going to try and bend it back in and see if anything fails here. So I'm going to push it in right about there. I've got 1/4 of an inch of the inner sleeve in the jaws. We've got some compression force on there. And then 1, 2, 3 bending. Alright. Alright. Back the same amount. So reversing the bend, we'll see if anything splits. There is splitting on the welds, the main welds.
Oh, you split the core.
The core split. The welds, the plug welds are still holding. So, under my assumption, if the welds do get full penetration with the core, the only thing that should fail is the weld seams or any kind of structural damage. I'm going to put it back in and, on this side. I'm going to try and see if we can just completely split in half to get a full idea of what the weld structure looks like on the inside. So, find where that sleeve is. Go about there. Another twist in. Tight. So we have clamp on both pieces. Alright, full separation. And the plug welds are still holding. So, as is designed, the structural integrity of the base steel failed before the actual weld was holding piece together. So look at the two. There is some full penetration on this weld right here that did not fail. In the light, you can see it is tied in. There's a little bit of full penetration here. There's a little bit of full penetration right there. Plug welds are strong. They held in all spaces. There's no separation of plug welds on either side.
Okay, so now as you can see from the video, these both test pieces failed ultimately, and what we suspect is not really toward the fatigue side, but more toward the ultimate tensile strength test. But again, that doesn't affect us to find out these new, very interesting findings. So I will let Ron and Parks to give a quick introduction with the actual test piece and to let everybody know what's going on. Please.
So my name is Ren. I've been at Savannah Tech for about a year, and I've been working on this chassis project for about 3 days now.
I'm Parks. I've been at Savannah Tech about 1.5 to 2 years, and I've been working on this chassis for about 5 days.
So in the mock-up of the original chassis build, we took the exterior tubing and inner tubing, we took the weld joint area and just condensed it, made a short mock-up about 6.5 inches long in total length with a 4-inch inner tube, and the spot welds placed roughly on 2 different faces, 1/2 inch away from the weld joint, and then on the other 2 faces, about 1.5 inches away from the weld joint. On one of these, we achieved full penetration to the inner tube, and on the other one, we only penetrated the exterior tube. As you saw in the video, for the full penetration tubing, the weld broke just at the edge, or the tubing broke just at the edge of the weld. And the heat affected zone is most likely the cause of that. The spot welds held up well. The weld is still tied into the inner tube, and it took roughly 3 bends and pretty heavily deformed the ends of the exterior tube in order to break this.
And none of the plug weld broke.
Yeah, none of the plug welds broke. The actual weld did not break either. It was just the metal right at the edge of the heat affected zone.
For this one, this only penetrated the outside tube. This one had very similar results. It broke on the edge of the weld, not the weld itself, but it did not crumple as much as that one did. And same thing again, the spot welds held up great.
This no penetration piece, however, only held up to 2 bends.
2 bends.
Yeah, and these were bent roughly 15 to 30 degrees in opposite directions until the joint had completely failed. So we were attempting to simulate fatigue to a certain extent. Obviously, we didn't have the best equipment to do so, but you get an idea of where cracks will start to form with fatigue based off of just where the weakest parts of the joint are in general. So while we shouldn't conflate the two, there are a lot of similarities that we should pay attention to.
All right, so thank you very much, gentlemen. That was a great explanation and a very excited findings, because we were just talking about that, and I never expected we actually complete this test and having a solid result that we can rely on. At this moment, I want to give credit to my teacher, John Glimmery. He already told me that's going to be the result. Of course, I didn't trust him. But you're right again. Okay, so with the test result, I believe again, instead of a repeat very light load that most race car is going to suffer from, say over 50 hertz of vibration, and for such extent of time, this is more simulating to a higher load, more toward when the impact happened. And the good thing we find out is, disregard which layout, the weld is not going to be the weakest link. The plug welds holds in place really well, which means there's, even I'm expecting there's a relative movement between the inner and outer tubing. By the way, they are really tight tolerance and pressed in together. So they still fail at the same time. And for some reason, if a full penetration will provide a stronger ultimate tensile strength, or the failing point, then I guess from the impact perspective, I would rather choose to have a full penetration, which I lost a bet, and Ron was correct. And in regard to the fatigue, I think elsewhere will fail before this point for sure, because the old chassis, they're actually brazed together, and the brazing is going to be considered weaker than the actual metal to metal joining, welding with proper penetration. So this is to me, very valuable testing and a very useful result. I really appreciate you guys. And Professor Marcus as well, and you guys did an excellent job, and I guess we'll just carry on and finish this chassis. Thank you.
Absolutely.
Thank you everybody.